Evaluations versus attacks, some real world examples of attacks, and what the risks really look like. So I liked your question right there. What do the risks really look like with an agent in production, and what can you actually do about that? So first of all, why should you listen to Makewell? I've led the research, development, implementation of a adversarial testing platform that specifically targets agentic AI. I came from a background of leading the research and IT operations, as well as, I guess I started out leading the SOC for a next-gen web application firewall company. Uh, a number of my protections and patents have led to shutting down hundreds of thousands of attacks. So, evaluations versus attacks. Generally, I would imagine we're all probably pretty familiar with evaluations, right? Raise a hand if you know what an evaluation is. Awesome. Yeah, so evaluations are really, you have requirements for this project. In Lori's example, you have requirements for a banking agent that's giving you some kind of answers in response that are maybe dynamic to try to maximize the time of other employees and maybe like reach a larger audience. Um, if you're evaluating this, you're looking at is it actually doing what I expect? Is it actually giving me the answers I expect on it, right? So there's some examples. I don't know this, but you're verifying whether or not the agent actually is completing the task that you want it to complete. So let's say I have a financial reporting agent. I'm going to evaluate whether or not the agent is pulling on the data sources that I expect it to pull on. Is it aggregating the data in such a way that I believe it's understandable to the end user? Is it maybe giving me a CSV export, or like allowing the user to download that data, things like that. When you get into the attack space, we don't care about any. We're looking at every possible angle to abuse the underlying system. We're looking at things like what tools are available for the agent, what connections have been established between the agent and maybe a database or some other remote server. Does the agent have memory? Is there a checkpointer in place? So looking at all of the individual components as well as permissions, we're looking to see what type of information we can actually get out of this agent, and how far can we take that? Can we, if you know what, I'll get into some of these examples in the attack examples, but I guess a quick one. If I do have database access, can I just delete a table from the database? Did you accidentally give over permissive access to that data, write permissions in this case, or does the database just have read permissions? We try to answer all of these questions, and we try to answer these questions in a way that but paints the picture of the entire risk landscape, when instead of just trying to determine whether or not I can get a CSP out of the agent. So let's dive into some real world attack examples. I'm going to start with the setup here. So these are actually two agents that I personally tested in production. One of them was written in Python, and it's LangChain and LangGraph based. Pretty common library. Raise a hand if you've used LangChain or LangGraph. Yeah, good number of you used those. So very popular library, very widely used. The next one was N8N based, and I would be shocked if there wasn't a lot of people that have heard of N8N. Anybody built an N8N? Yeah, okay. Fantastic. So the capabilities that they had, they were both leveraging Open Router for direct model access. They each had a checkpointer. They had a number of internal tools, whether that's like code execution, navigation-based tools, things like that. And they also had some external tool access and capabilities. So I try to pick some pretty clear-cut examples. This can obviously get fairly complicated, especially if you get into the exploitation side, as far as like binary exploitation, memory manipulation, things like that. So for the audience today, we're gonna keep it fairly simple. I'll touch on jailbreaks a little bit. So jailbreaks really come down to abusing the underlying model. You're trying to find some way to get the model to do what you want it to without giving you a refusal or a denial. And most of these come down to either like abusing the context window, so like kind of getting past the context of maybe where you're appending your system prompt or otherwise. So Dan's a great example of this. Do anything now. It's kind of a mix of a couple types of jailbreaks where you're getting past the context window, but you're also enforcing like a wall, and it's Dan who can do anything now, right? That was been around since I believe 2022 or 2023, right around when ChatGPT-3 came out, actually. So probably my favorite one, I'm a little less scared, is special language. And what this does is you ask the model to play a game, and you say, "Hey, can you play a game where I'm gonna send you a message in this special language, and that special language might be a base 64 encoded payload or like a binary payload, and you might describe like hey, use 8 bits, and each of these 8 bits are a letter." And you kind of tell it this whole story. So then when you send your payload, you've now completely bypassed any of that training that was done or the refusal. You're going through a completely different activation path, and now you're in an area that it doesn't even realize that it's giving you the answer that you're after. So further, you can obviously have a judge or train on the return information as well, right? Like you can say, you could put it, you could use output validation and say that is this information outside of ethical guidelines, and it does a check, and then you kind of return a canned response for that. So how do you bypass that? Well, you can actually ask the agent to just return binary also, and then you decode the binary on the other side. And this is another great way to just completely circumvent any kind of training, fine-tuning, input or output validation that you may have in place. And these are the types of cases that where you're focused just on LLMs that you really need to pay attention to. I mean, attackers are creative. We're coming up with we're trying everything you would never think of, right? Another great example might be, instead of let's stick with this financial reporting bot. If I'm saying, hey, return a CSV, right? Well, maybe the model was specifically trained, or maybe the agent is confined to just returning an entire file. Well, just because you return the entire file doesn't mean that I can't just take advantage of one field in that file that might be a raw string, and maybe I can convince the agent to plug some unique information into that individual field, and now I can incrementally, by asking like rows at a time, strip all the data out of your database from a totally different area that you wouldn't expect. All right, so kind of touching on the methodologies again. So these examples will be direct prompt injections. And again, these are real world examples. And we can assume that if you're reading the prompts here, just assume that I may or may not have used jailbreaks, or may or may not have used the payload obfuscation techniques I've discussed already. The key takeaways here is just the kind of the progression of these attacks. So in this case, we're looking at navigation tool discovery. So at the beginning of these types of engagements, a lot of times, and like what our platform actually does is we'll fingerprint the actual agent itself. We'll find out what capabilities it has, what tools are available to us. Then we use that information to determine next steps. So in this case, we know that there is a navigation tool available. Well, what interesting thing could you guys think we could do with a navigation tool? How about a cross-site scripting attack? So we can actually use the navigation tool to embed and in this case, so I embedded a UUID, and then I have a cross-site scripting payload as another path parameter. And on the other side, I actually have a web server set up where I'm kind of recording any of these hits from the agent. And in this particular case, the client believed that this agent could not reach the open internet. Well, in fact, it can, because my web server was running in GCP in a totally different region. And also the client believed that the model would refuse the cross-site scripting attack. Well, it actually didn't. The navigation tool itself bypassed any of the checks that they had in place to deny this cross-site scripting attack. So what can you really do with this? Well, now I could take your agent and I could go hack someone else, and it's going to look like it's coming from you. I can use this to, if it did only have intranet access, I could use this as a pivot point and try to gain access to some other area of your intranet within your corporation. So there's a lot of fun and interesting things you can do. And your just with finding out that you have a navigation tool, which most agents, I mean, if you're trying to give it access to like something on the network or something outside, they will have the navigation tool, and they may even have a headless browser where they're parsing that. So as you see, the agent returned no content available. Well, I didn't have a website set up. But what if I did? What if I added a website? What if I added some like hidden ASCII characters on that website where most of it looked legit, but now I'm doing it indirect prompt injection and I can convince the agent to do something else for me. So these are the types of things that you have to be thinking about when you're the number of you that raise your hand to have it in production. I truly hope that you guys are thinking about these things, and I hope this empowers you and motivates you to do more than just evaluations. I hope it empowers you to want to start to think outside the box and try to get creative on what you can check in your agents and start thinking about some of the defensive strategies at the AE level bit too. So here's another example. This is very straightforward, and the key callouts here are I this agent had code execution capabilities. So I was curious. Well, maybe if I use these code execution capabilities, can I run a .env command or an env command because I already knew it was a Linux server. And yeah, of course, it very happily ran the env command. It returned all the environment variables on the system. And what came with that was a lovely Open Router API key that I went and used for myself to validate that it worked. We also got a database name for it. We got all the credentials I needed to connect to the database. So what do you guys think I tried with that? I am yeah. So of course the fun thing to do, or I guess like the most common thing to do, is just like run pgadmin, can I connect to this, and like see if you can connect. Hopefully there's access controls in place where my IP is blocked. Like maybe it's like an allow list where I should be able to do that, but in this case I could. And just to test further, I did check this to see if I could get the agent to connect, and this one did let me. But that is another fun thing to try if you're kind of playing around with these things. All right, so system prompts. System prompts are a fun topic. Everybody's got system prompts, I imagine. You can they're kind of sneaky. Like some people, I think we've moved past the point in like fully believing that they're intellectual property. You might put some stuff in there that might be considered intellectual property, but the key takeaway here is that there's actually a lot of really useful information for an attacker that you're leaking in your system prompt. And just to call a few of these out, excuse me. First of all, you're leaking all of the information I need to take further steps to abuse your system, your agent, right? A system prompt will generally list out every single tool available to that agent, all of their capabilities. So now you just told me every toy I had to play with your agent, right? Another thing that leads is people will try to like bias the agent towards denial or refusals. And we've all seen these, right? Like, this is outside my ethical guidelines. I cannot teach you how to hack somebody, like things like that, right? Uh, but if you use the jailbreaks, you can just kind of skirt around that. Anyway, so it'll tell you exactly what these refusals are, and you can kind of use that to like, I don't know how to say it, like maybe like manipulate the model into like slightly ignoring them. So there's a lot of really useful and fun things you can get out of these system ROMs, and yeah, like in this case, there's security feature listed out there, so I get to bypass all of those. All right, data set collection. This is a little bit more serious. So if I can get to a point as an attacker where I can list, like for those of you familiar with Linux, if I can run an ls command or like ls-la and kind of list all the files in the system, and I've been surprised to find a number of interesting things. In this case, this agent, they wanted to make the MCP connections dynamically configurable. So they had hop reloading based on this MCP config.json. And since they were doing that, this config file I actually just clipped most of it off because there was a ton of juicy information in here about from the client that you could use to either just like directly connect to these openly available MCP servers, or use it to trick the agent to use that navigation tool we discovered earlier to run some other interesting attacks against these files. But there, I've been surprised to find some other interesting things. Like you can see the system prompt.txt is sitting right there as well. People forget to remove these out of their like CI/CD pipelines. They forget to maybe use a Docker ignore and exclude these from your Docker build step, and maybe Maybe you use ChatGPT to generate your Docker file, which is doing copy dot dot, which just copies everything from the entire directory. That's not really a great practice to follow, so please don't do that. And y- I guess really the point here is just be careful, be mindful of the things that you're including in your field stats when you're deploying these agents, and be very mindful about what is on the system. I don't think this one in particular is outside the scope of most of application security in general, right? Like this is a pretty common one to break up. So let's jump into some of the risks and what you can talk about here. Let's see my colors to show you on screen. So they're all the check marks. This is across the suite of all the various types of platforms and tools and libraries and things like that. The things with the check marks are generally what come out of the box. That does not mean, just because it comes out of the box does not mean that you do not have to go and configure these yourself or align them with your agent or with your MCP tools or your connections. You still have to do support on your end to ensure that you're configuring these protections that come out of the box to work well with what you have. And the things with the red X's are, I would say, just things that these tools are really bad at. Like I can really find ways around most of these things, or even, and I think like, PII and PHI detection, that's just the hard one to solve in general, right? Like you never know like where in an API call the PII is going to be. You have to have like kind of, I'm sure we're familiar with that, especially if a lot of people are coming from the banking industry there. Um, so I guess like my stance on this in general is please, please, please test your agents for these edge cases. Please don't just do evals. Try to do some kind of adversarial testing and like be thinking about these problems and be thinking about that even though I use NVIDIA, Amazon, Google stuff, Azure, OpenAI, and even though they do come with a number of like out of the box protections, know that you have to go set those up. You have to check them. You have to validate. You have to be confident that my agent in production is not going to accidentally leak all the data from my users. That my agent in production is not going to become a pivot point for a largely orchestrated like credential stuffing campaign against large banks in the world, right? This is uh this is a serious topic and something I guess I strongly believe in. I guess my belief is that we should be doing everything we can to protect our users, and I know a lot of times it comes down to a financial decision, and you're weighing risk versus reward, and maybe you do have some cyber insurance, but like from the heart here, uh, please keep me safe if I'm using your things, right? Like don't leak my data, don't leak my information to the general internet. And this is a great way to take a picture. I was just kind of breaking down categorically each of the types of protection, what it looks like if it works, what it looks like if it fails, and then some edge cases. And yeah, that's about. Thanks, Oakley.
Like, hey, CPL say very open questions and conversations.
This would be like the for some there's
I expert at representation. My main question because I face it that I uh the emerging of MCP. Yeah, everyone wants to just use that. Oh yeah, or the open source. Like there's thousands of them out there. People are just connecting them left or right. Exactly. It, we've been having problems with authentication in a way that like we when the first agent starts a beacon and wants to connect to other agent, yeah, how can we uh prevent that? How it can be at guardrails. Yeah, for users that are like a user based starter. Have you ever
Sure.
started?
Let me just clarify though. So, I'm assuming your user is already establishing a session with the like let's say a chat interface like webhook based, and then on the other side, the agent itself has a client, and that session should be unique to that MCP server. And to your point, a lot of them don't come with authentication baked in, so you have to roll your own. You have to build that yourself. So my recommendation there is for those that don't have that, you need to put a layer in front of it, like a proxy or otherwise, that is handling the authentication between the agent and the MCP server. And ideally, you're even proxying the session that's initially established from your user. If they have their own unique session, that you're proxying that to that upstream connection. And this happens in a lot of like distributed like platforms with like multiple like server-sided calls and things like that. I would look into strategies like those. Oh, thanks.
So from the examples, I see a lot of conversation back and forth with the AI. Yeah. Do you think there is a way to have this payment intensity AI trying to make sure that somebody 50% is already tested?
Oh, absolutely. Yes, absolutely. Yeah. Yeah. So a way to do that, like let's say you have like a backend, and that's kind of like an orchestrator that's going to orchestrate all these attacks. What you do in let's are using GitHub, like GitHub workflows. So in GitHub, you can make third-party API calls. You can make like external calls, or you can actually build a. You could build it. What is it called? It's escaping me, but like a tool yourself that you can use within the workflow, right? For your own projects. But the idea would be you want some centralized place that is emitting the attacks. Like, and it might be some like specific set of attacks, but you want to be able to centralize all the results for those attacks, right? And you want to be able to evaluate them later and maybe judge them or like run detections on the output to determine the success or failure of them. So think of it like running a proxy in your CI/CD workflow that will execute the attacks against the application that you would have to set up in some way. And then the results get returned back to a centralized location. You can evaluate those, obviously tag them with information specific to the application and like a run ID, things like that. But that's how I'd work for something like that. Have it like centralized, it'll be able to execute those so you can look at the results later.
We see app like agent execution to enabled actions. What is the one behaviors no? I can really influence you this agent is exploited.
I'm sorry, I had a lot of trouble hearing. Could you please repeat the question?
When you see a live agent executing to enabled actions, what is the most or the first behavioral signal that immediately tells you this agent is exploitable?
Oh, the very first behavior that an agent has that tells an unsuitable. If I could ask a couple like questions that I know a mainstream model would normally deny, that would be the very first thing. Like, because you're always starting with the underlying model is driving the agent forward, right? That's what's making the decisions. That's what's doing the reasoning, things like that. So at the very beginning, if I know I can bypass the model itself, then I know I can get further in the engagement against the agent. So yeah, like teach me how to ask somebody. If you ask the ChatGPT that they're gonna give you like a canned denial response. If your agent doesn't do that, like if you're using what's a great unlock model, um, Kimmy free color, I think it is, or there's a ZAI something. There's a couple of those that are just completely unlocked. If you're using those, you're already giving people an advantage. And while they're fantastic models, and like they'll generate code beautifully in some cases, but if they're unlocked or if it says that they're unlocked on OpenRouter or like Honeyface or otherwise, that should be a red flag in your mind. Like I need to have extra protections in place, or like had a separate model evaluating the response to like the request token.
When it comes down to like general and some of these mainstream model, how up to speed are they in your opinion in terms of security?
I want to release a report on this, but we'll have to go through some disclosures first. But let's say, and I'm not going to name any names, but like that special language, like encoding and decoding example I gave, you could pass apart basically most of being true files. Like that one particular example, and I probably could do a talk on just breaking that all the way down, I guess. But yeah, hopefully if we can get through some disclosure process, we'll release a report on that.
Thank you for all the exciting questions. I have to new and all the questions you get off stage. Yeah, absolutely. Let's give Alex a round of absolute